Welcome to the introductory session of Diploma in Geotechnical Engineering, Geotechnical Tunnel Design. I'm so excited to have everybody here. At first, I think I should introduce myself. My name is Bahareh Mohammadi-Haji. I'm a civil engineer and a Ph.D. of Geotechnical Engineering. I have worked on seismic behavior of tunnels extensively during my PhD thesis and worked using performance-based analysis concept and also advanced soil constitutive models. We will discuss the importance of both concepts, performance-based analysis and soil constitutive models, advanced soil constitutive models later. I have 10 years experience in industry dealing with various geotechnical projects. I want to share my screen with you. Let me share it. Okay. Okay, here in the table, you can see some of my experiences, geotechnical study and foundation design, deep excavation design, underground structure design, and also soil improvement. And also, I have published several papers in soil dynamic and earthquake engineering, geotechnical and geological engineering, computers and geotechnic journals. I think now let's talk about a little about the diploma in general and diploma in general, and then we will go through the detail of subtitles. The purpose of this diploma is to provide a considerable theoretical and practical knowledge in the area of design and construction of tunnels. The issues that we are gonna discuss here will be helpful for somebody with or without experience in this area, as we review basic concepts and then go further to practical materials. Generally, I can say that this diploma is gonna provide a package including tunnel-related information, definitions, and concepts, also design and construction methods. It will be potentially fruitful for somebody who would like to be involved in tunneling projects as a client, designer, constructor member, or supervisor. Please pay attention to this slide. Let me use laser point. Okay, if you want to serve as a client, this diploma is gonna be useful for you, or you wanted to participate in design as a designer in geotechnical design or structural design. It will be helpful if you can serve as a constructor in both technical group or execution group, also a supervisor in the quality control team, quality assurance team, monitoring team, or test during construction, or as an operator in a repair and service team. Also, diploma in geotechnical tunnel design tries to provide these abilities for you. Define the characteristics and the mechanical properties, strengths and failure criteria of geotechnical materials, explain methods and required procedure for geotechnical studies of tunnels, use rock mass classification systems, RMR, Q, GSI, and their relation with primary design of tunnels. It helps understanding different tunneling methods comprising mechanized and traditional approaches, construction methods, and common and extra support systems. Understanding the application of numerical methods for analysis of tunnels, design of structural support systems, and seismic design of tunnels. Also, I will share my studies, researchers' experiences with you, so highly advised to take part in this diploma. Let us review the tunnel definition here. Tunnel is an underground structure dug through the surrounding soil or rock without disturbing the overlaying soil or rock cover. Here are some highlights of tunnel projects. In tunnel projects, prevention of disruption or interaction with surface life, including traffic throughout construction. What does it mean? It means that we are under the earth, we are underground, so the normal life could happen on the top of the ground without any disruption for the people, for the lives of the citizens. Tunnels are environmental and ecosystem friendly. Yeah, it's an important issue in recent years, of course, and tunnels are convenient and economical alternative in comparison with other transportation options. For example, bridges, in comparison with bridges. During construction, due to the complexities of the ground condition, the primary assumptions will be changed and the design may be accordingly updated and optimized. It means learn as you go. I will explain it later. Here is a table, a comparative table between above ground construction and tunnel constructions. As an environmental point of view, tunnel construction is in a more compatibility mode with comparison with above ground construction. As an architectural point of view, above ground structures have more interference. Also, loads for above ground constructions are generally known, but the tunnel loads are based on assumptions. The safety mode for factors for both above ground construction and tunnel construction are the same, and the cost is a little more in tunnel constructions. Well, design, calculation, and construction of underground structures, such as tunnels, is one of the most challenging and complicated topics in civil engineering. It comes from the fact that tunnel structures integrate the concepts of structural and geotechnical engineering, and one of the salient phases of soil structure interaction problem is the analysis of tunnels. Besides, design and calculation process have to take into consideration construction methods and stages. Another point to consider is that monitoring continues till the end of the project and the design. Methods and calculation may be updated during construction. In tunneling project, we have the expression of learn as you go, as I told before. It means that more we progress the construction, the deeper we understand the condition of geotechnical material. Well, the big portion of today is gonna be reviewing the modules of the diploma to get familiar with each part. Module 1, Geotechnical Investigations and Considerations used for tunnel projects, tunneling methods, explanations, and comparison. Module 2, NATM or SEM method. Module 3, cut and cover, cover and cut, open trench method, and other methods. Module 4, TBM. Module 5, soil constitutive models. Module 6, design under static loads. Module 7, design under seismic loads. And Module 8, refer to thesis projects. Start with Module 1. Module 1 covers the geotechnical investigation and consideration used for tunnel projects. As a matter of fact, geotechnical conditions are crucial factors in design and construction of underground structures, as well as tunnels. When I say crucial, I mean that they potentially could highly influence design outcomes and construction methods. For example, suppose facing high groundwater pressure in a tunnel project. Such kind of problems may suspend the project for months if the designer didn't have primary knowledge about that. While on the other hand, if there is a prior knowledge about it, the problem can be solved by in many ways by changing the route or considering retaining or proper drainage at a proper place. And I think all of you have already known the soil laboratory test. So we will summary of them for here. For example, I'm talking about a direct shear test, triaxial, plasticity index, etc. So we can achieve mechanical and other specification of soil or rock medium. Here, we will concentrate more on field investigation because although these methods are more expensive, they usually result in more economical and optimized design. In situ techniques, in spite of their resulting high costs, could be cost-effective for project in general. We will learn intrusive and non-intrusive in situ methods, and the parameters and information can be attained by them. Geophysical way are very beneficial in line tunnels that we don't have access to the whole length of tunnel at the beginning of the project. So here we have geophysical methods, non-intrusive and intrusive methods, and the subdivided, we divided into 4 categories: seismic method, resistivity, conductivity, borehole geophysical logging, cross-hole seismic techniques, and intrusive methods divided to standard penetration test, cone penetration test, pressure meter, and double load plate test. We will discuss them in detail during the diploma. Here are in situ techniques. In spite of their relatively high cost, could be cost effective for project in general, I have told before. And at the end of module 1, we will go through the tunnel construction techniques, traditional and mechanized one in a brief. The most commonly used tunneling methods are NATM or SEM and TBM. A designer should be familiar with both methods, although specializes in one of them. So here we will go through both methods deeply enough in order to understand the specification, conditions of 2 methods, and a general comparison between these 2 methods. NATM method that can be called sequential excavation method, including tunnel section, which has been divided into several excavation parts, depending on the geotechnical conditions. When I say geotechnical condition, it means overburden, tunnel dimensions, and maybe ground parameters. In this method, excavation of the tunnel section is aligned with geotechnical monitoring. This method surely has advantages and disadvantages. One of the most important things about this method is that excavation of the tunnel section is accompanied by monitoring, continuous monitoring, I mean. We're gonna explain why it is useful. Soil mass around the lining of the tunnel contributes to load bearing and help to withstand against the loads. So total overburden loads won't be sustained by the tunnel lining due to the arching. This phenomena will be extensively discussed in the relevant section during diploma. Also, this method is an economical method, flexible for different kind of situations. On the other hand, large deformations and a high number of stages of excavation steps that makes slow progress are some of these disadvantages. The probable configuration in different conditions will be discussed in this module. A series of practical example, tunnel section also will be shown to attract your interest. Here you can see a typical NATM section. This is the real section. And also, let me have an introduction with the TBM. TBM method, or mechanized tunneling method, or shield tunneling, or tunneling boring machine, all refer to the same method. For large span tunnels, failure mechanisms are highly probable, and using a TBM seems rational in that cases. This method also applicable in frozen soils, weak or saturated soils. It has a faster progress in comparison with NATM method considerably, and usually it is more economical for long tunnels with uniform sections. I emphasize long tunnels with uniform sections. It means that when we are dealing with or facing with several tunnel traffic sections, for example, two lanes or 3 lanes route, or can we have combination and connection of the two different underground routes, TBM doesn't prove to be the best solution. TBM is categorized in different ways. We divided them based on the phase stabilizing technique in one hand, and on the other hand, based on the advancing approach. Furthermore, we have EPB or slurry shield, so on, while we have single and double shield TBMs. These are some pictures of this kind of tunnel. In the next module 2, we will go deeply to the NATM or SEM tunneling method. New Australian tunneling method. Now I want to speak more about it. That was developed between 1957 and 1975 in Austria. Is an approach integrates or the principle of ground behavior under load and monitoring the performance of underground construction during its construction. Other names of these methods are as below: sequential excavation method, spray concrete lining, or in Japan they called cross diaphragm method, or upper half vertical subdivision methods. The left picture is a typical section of an NATM tunnel, and it divided into 3 parts. It shows the excavation stages. And this picture in the right hand is the longitudinal profile of the tunnel. You can see the stages of the excavation. And here is the real shape of another section of the NATM tunnel. Well, here in the module 3, cut and cover, cover and cut, open trench methods and other methods will be described. Before going through the open trench methods or cut and cover and cover and cut, I wanted to first talk about other techniques, other mining techniques, such as rib method. Rib method, like NATM method, is a mining method, and please pay attention to this figure. As can be seen in this figure, main tunnel is surrounded by series of structural elements. It is called rib method or Russian method. These elements, this pile these beams are large concrete beams and piles. They are constructed before the construction of main tunnel to increase the safety during excavation. They commonly are employed when we have large sections in weak soils, for example, metro stations. Look here, in all these sections, there are piles and beams constructed before the construction of the tunnel started. So the way these elements are constructed will be explained in the module 3 by detail. And let's go back to the cut and cover. Okay, the module 3 covers the construction methodology and excavation systems for cut and cover roads, cover and cut on open trench. In cut and cover tunnels, the structure is built inside an excavation and covered with backfill material when the construction of the structure is complete. This method is normally used when the tunnel profile is shallow and the excavation from the surface is possible and economic and acceptable. This method divided into 2 categories of construction. First, bottom up, and second, top down. Bottom up method is that the final structure is dependent of the support excavation wall. Top down method is that the tunnel roof and tunnel ceiling are structural parts of the support of excavation walls. For construction of stations or underpassing assigned with NATM tunnel method, there are other mining methods such as REAP method that I speak about before. I will speak about before, spoken about. This method, okay. Cut and cover stations could be in diaphragm wall method, nailing on anchorage, or a strut and truss support. Also, we're gonna discuss other fortifying methods such as umbrella method, for poling, jet grouting in this module. In fact, these are soil improvement techniques which help accelerate the construction rate and increase the reliability and safety, generally in different conditions of the project site. According to the special situation, designers may use some innovative methods in tunneling, for example, in very loose or weak soil. Simply put, all methods we will discuss could be combined in different conditions to reach the best design, and that is the point that makes the tunneling challenging but interesting. Well, let's go to the next module. Tunnel boring machines, TBM, are the machines employed to excavate tunnels while supporting surrounding ground material with a circular cross-section. Several configurations were developed in various ground conditions. Elements to be made of TBM is a complex system with a main, a body, and other supporting elements to be made of mechanism for cutting, shoving, steering, gripping, shielding, exploratory drilling, and support lining, or etc. Tunneling equipment, said before, divided into the 2 categories according to the medium, as can be seen in this slide. It divided into soft ground, used for soft ground, and for hard ground or rock. And there's this 2 subdivisions: homogeneous or complex confined boulder, also complex hard ground or homogeneous ground. It should be indicated that supporting systems here in TBM differ from what is in NATM. We don't have initial and final lining. We have segmental lining as both initial and final lining. The mobilized forces, therefore, depends on construction method that we will talk about later. Well, Module 5. Module 5 covers the constitutive models, soil and rock constitutive models, soil basic models like MC model, HS model, HS small strain model. MC model refer to more column model, HS model refer to hardening soil model, and HSS refers to hardening soil model with a small strain. Soil advanced constitutive model, hypoplastic soil model will discuss here, and at the end, rock mechanics and models will be discussed. Numerical modeling of geotechnical structures precisely is highly dependent to the soil behavior. It means that the necessity to accurate prediction of the soil behavior in numerical modeling leads to the development of advanced soil constitutive models. Ordinary, simple stress strain behavior of soil may be satisfying in some cases, but when we are talking about tunnels, underground structures with many complicated behavior, interactions, it should be studied more. It needs more study. Well, look at here. There are three diagrams, shows three kind of stress strain behavior of the soil models. This diagram related to the MC model or more column model. You can see the linear behavior until the specified strain here. The loading and unloading paths are similar in this model, and it is definitely not proper for seismic describe the seismic behavior of underground structure, because it cannot produce hysteresis loops, dampings, and also it cannot see the interactions properly. This diagram in the bottom shows the hardening soil model behavior. It is not linear anymore, but it still has the same loading, reloading path, and this is not good for us. In many cases, we wanted to monitor the dynamic behavior of underground structures. This one, the third one, which is a smaller strain, hardening soil with a smaller strain. It is a modification of the last one. So you can see the hysteresis loop here. It can generate a hysteresis loop under dynamic loading. It can see damping. Here it is not. It is a nonlinear behavior of a stress strain of the soil, and also the loading and unloading paths are not the same in this model. And sophisticated dynamic model, hypoplastic soil model. This model, among these models, sophisticated model, it is comprehensive and rate-dependent model, and properly describe the nonlinear stress-strain behavior of soil. This is the rate-dependent equation. It is a strain rate dependent, and these diagrams show the logarithmic and linear relation between parameters PAS, EI, EC, ED, which are pressure, initial void ratio, critical void ratio, and minimum void ratio. And this gray part shows the impossible state for the soil grains, and this model can properly simulate soil dynamic behavior and hysteresis loop and can generate during seismic excitation. It also can show soil structure interaction very well. You can see the tensorial equation of this model here, as I said before. And let's have a talk about the rock mechanics and models. Okay, rock mechanics, simple approaches to take into consideration discrete specification of rock shall be described. Due to geotechnical conditions and the nature of rocks, there are issues in the design of tunnels in rock medium that are not in the design of tunnels in soil medium. Soil is homogeneous, soil can be considered isotropic, soil can be considered continuous, but what about rocks? There are generally cracks, have cracks, joints, faults that make the behavior of rocks complicated. However, it should be said that it does not mean that tunnel support in rock is more costly in comparison to soil tunnels. Generally, in most cases, tunnel lining in rock are lighter, even though there are points that should be taken into consideration in design of tunnels in rock. I will try to present the methods that consider the rock specifications in the design process. First, we should know these specifications. Afterwards, how to convert a continuous rock model to a simple continuum model that consider most its specifications. Here, you can see, you can compare soil to the rock. And simple approaches to take into consideration discrete specification of rock shall be described. Rock mass behavior is the first step. The theories Terzaghi, Loffer, Hoek can be used to explain the behavior, and the geological strength index then can be achieved from Hooke-Brown failure envelope with these two parameters, and the design with numerical modeling will then we got to the model 6, design under static loads. But first, I wanted to review a little about the NATM tunnel. We told you that the most commonly used tunneling method is NATM or SEM. And NATM method can be called sequential excavation method, I told you, including tunnel sections that are divided into several excavation parts, depending on the geotechnical conditions. I show you some pictures of NATM sections. In this method, excavation of the tunnel section is aligned with geotechnical monitoring, and so you can update the methods and the construction stages in every stage. And I told that one of the most important things about this method is that excavation of the tunnel section is continuous, and with monitoring, we are gonna explain why it is useful. And here we wanted to speak about the design process and phases under static loads. Usually follows as this chart. At first stage, we should define ground type and every related issue to the geotechnical considerations. In the next step, we would be selecting soil and rock constitutive behavior. Then the structure should be analyzed considering methods and stages. And now it's the time for designing of support elements and initial lining. In this part, we are gonna talk about the design construction material properties in detail. For example, in the absence of the precise calculation, beam stiffness could be assumed 50% of the uncracked section of mentioned beam in restraint frames due to the ACI. And then we go to the design of final lining and the monitoring and back analysis and redesign. So the next slide, you can see shotcrete and lattice elements. Here, look at the right picture. These elements are called lattice girder. These are prefabricated elements built out of tunnel and then brought inside and installed. These are, in fact, prefabricated rebars in the shotcrete, and initial lining is composed of shotcrete and lattice girders. Here in this picture, you can see the lattice that installed in the tunnel and the shotcrete that are covering it. These have been developed for special demands in the field of tunneling. This system has been evaluated and employed very well all around the world, and the lattices provide immediate support in an open span area. These elements are integrated in the shotcrete. Shotcrete means spray concrete. When I say shotcrete, I mean the spray concrete. As stated at the last, we have a reinforced shotcrete element with a thickness of around 10 to 40 centimeters. This is called initial support, supposed to withstand against temporary forces from the soil interface. As said before, monitoring during construction and back analysis and redesign, if needed, would be the last level. Here, monitoring, back analysis, and redesign if needed. Well, we stated before, NATM tunnels have two kinds of lining called initial and final lining. I speak about lattice and shotcrete, the combination of lattice and shotcrete as an initial lining, and it's a temporary part which normally doesn't have to have workability for a long time. The workability or efficiency duration for initial lining is less than 2 years. So the seismic loads doesn't consider in designing initial linings. On the other hand, there would be an obligation to construct final lining in its section of the tunnel before 2 years from the completion of the initial lining construction. Several approaches are, and here you can see the final lining or permanent linings. Several approaches are employed to analyze the underground structures comprising closed form solutions and soil structure interaction methods. These are to calculate the mobilized force and influence of construction on the adjacent and above ground facilities. And module 6, design under static loads. The calculation method can be divided into two groups: experimental method and a numerical method. Experimental method can be called simple method or closed form method also. And the convergence and confinement method is a common method which is simply consider soil structure interactions. Also, it can consider soil properties, lining stiffness, and delay in its construction. Of course, there are some techniques to overcome the simplification which we use in this method and will be discussed later during the diploma. Generally, this method is based on the relative displacement of the opposite points on the tunnel wall. Following the convergence of the tunnel section provides the possibility of controlling the appropriate retaining, following the convergence of the tunnel section provides the possibility of controlling the appropriate of retaining and forecasting and the required reinforcement if necessary. From my point of view, this concept should be understood perfectly before we can go further if we would like to have deep insight of a tunnel behavior in different conditions. Even if we are going to design a tunnel by numerical simulations, convergence confinement concept is used during process. Another point to explain will be the simple method to conduct two-dimensional modeling. Tunneling construction, in fact, is a 3D problem and will require some tricks for simplifications. In the numerical modeling is usually analyze the plane strain condition. And in order to simulate the excavation stages that are in fact a 3D physical issues, the numerical model use the stress release ratio. So here we have a 3D problem, which is the construction stages in the tunnel, NATM tunnel, and we wanted to use a 2D models. So the concept of a relaxation factor or release ratio generates here in numerical modeling. These are the most effective approaches, I think. However, there are other methods that we will review overall, because tunnels are 3D, converting the structure to a 2D numerical model can increase forces. For realistic modeling of a 3D nature to a 2D model, relaxation factor are used. The way to estimate relaxation factor is related to the concept of convergence confinement, as we introduced before. I told that if one wanted to have a deep insight of a tunnel behavior in different conditions, should have the good insight about the convergence confinement method. So the equations and the most common ways to assume a proper relaxation factor will be presented in the future during the diploma. Okay, Module 7. Module 7 is designed under seismic loads. It is complicated in two procedures. Seismic design and analysis of underground structures differ from that of above ground structures. The dynamic responses of above ground structures are evaluated by the inertial forces, which may be different from those of underground displacement. On the other hand, underground structures displacement does not differ significantly from the surrounded soil. Thus, their seismic responses are controlled by the ground strain, ground displacement, due to the soil structural interactions. The complexity of the seismic behavior of a raw structure depends on two factors. As can be seen here, the first factor is complicated soil dynamic behavior inherently. It means that soil inherently under dynamic loading or seismic loading have a very complicated behavior. And also, second one, complicated soil structural interactions. So the other point is that here we have another a structure inside the soil, and the interaction between these two may complicate the picture, the situations. So in the left side diagram, you can see a hysteresis loop of soil under seismic load. I should say that it is from my Ph.D. thesis and uses the advanced soil hypoplastic model, and it was perfect. I think it has the perfect simulation, and on the right side diagrams show the ratcheting phenomena here. These are showing ratcheting phenomena of the soil. We will discuss it completely in the following sessions. And the ratcheting, what's ratcheting? Let me explain a little about the ratcheting. And the smallest ranges of granular soil has incrementally nonlinear behavior with a high stiffness that gradually decrease with increasing the deviator stress. Soil model should be able to predict higher initial stiffness after reloading. If not, ratcheting eliminates. It means cumulative strain during cycles causes ratcheting, and it should be mentioned and it should be considered in the soil models. Well, pseudostatic force applied to the soil structure model. Earthquake is a dynamic phenomenon, and the most ideal approach to simulate the structure is under seismic event is nonlinear, fully dynamic analysis. Yeah, we know nonlinear, fully dynamic analysis is the best approach. However, as you may know, these methods are very complex, time-consuming, and costly. For this reason, in design process, we use a simple methods such as pseudostatic ones. But the point is that pseudostatic static analysis methods for above ground structures are completely different from that to be used for underground one. It is due to the fact that their dynamic responses are not the same during excitations. For general structures, inertial forces govern the behavior, while pseudostatic are more important for seismic evaluation of underground structures. We will talk about these expressions more in the future. This is a common method. It's called in design offices hashish or Wang method. In fact, it is a soil structure method which relates to the section, deflection, and the mobilized forces to the free field deformation. Here, please pay attention to this slide. Here is the they use the pseudostatic method in tunnel design and seismic design, tunnel design, and here we have the structural deformation into the free field deformation in this graph, and it shows the flexibility ratios that used in these equations to have the deformation of the top and the bottom of the tunnel, and we will discuss them extensively into the diploma duration. And here we have design under seismic loads, performance-based design or seismic risk analysis. Performance-based concept for a seismic design of structures have been used widely during 2 past decades. more for above ground structures. In these procedures, structure is designed in a way that its performance under seismic loading could be predicted to the acceptable level. In this method, levels of performance should be defined as well as levels or status of damages. In other words, when a tunnel is constructed in an earthquake-prone region, generating an earthquake-resistant design would be of major concern. These design procedures should assure adequate performance in relation to the inherent risks in structures at different levels of seismic motions. Generally, tunnels have been studied less often than surface structures using dynamic approaches because of the complexity of the soil and rock lining interactions. There are some gaps between geotechnical earthquake engineering and structural dynamics. Risk assessment of the infrastructures, such as the tunnels, are in predicting tunnel behavior under seismic loading, considering damage status is an important issue for governments because tunnels are infrastructures that designed for a long time, around maybe 50 years or more. On the other hand, they are vital artery during earthquake, and their damages should be predictable. Here you can see the process of the seismic risk analysis and performance-based analysis. We start with ground motion. We excite the ground motion to the model, and the response model or by the engineering demanded parameters or EDPs should be chosen, and the responses catched after the excitation, after generating the seismic earthquake and seismic and earthquake motions. And after that, we use physical damage and see the physical damage and categorize the physical damage of the engineering demand parameters. And then we can estimate the loss of the phenomena and seismic, and help the clients to choose in which level of damage or in which level of the in which level of damages we should the designer should design the structure, and it will help very much in the design. And here are the references, and I'm here if there is any question. Okay, is there any questions about the diploma, about the presentation? Will you provide necessary software and license during the course? I should say no. I go through the software Plexus, but I'm not. I'm not opening the software. I use the figures. I use the stages. I use the definitions and material properties, but I will not open it online in the class. But I will teach step by step the stages you need to experience in the modeling. Any other question? You're welcome. I can't hear you. Please turn on your microphone. Oh, Erica, are you?